if you're a researcher, you're not necessarily going to go digging for some PDF on a research software engineering website which has some documentation about how to write a research data management plan.
Welcome to the first episode of this new ByteSized series, and you just heard from Richard Acton, who explains how he came up with a simple and I think a very pragmatic way to keep track of almost all things around your research software and tools projects with a simple checklist. But before we tick our way through our checklists, just a few remarks about the new ByteSized program. And it's a training program which consists of short online classes of about an hour long, hence the name, during which you should be able to practice and learn some of the digital skills you might need in your work as a researcher. Each class is then followed up by a companion podcast episode published here at Code for Thought. The ByteSized series is not just for budding research software engineers or people who code, but tries to reach anyone in research who deals with digital technologies. It's part of the Step Up project, a collaboration between Imperial College London, King's College London, University College London and the University of Westminster. Funding comes from the Engineering and Physical Science Research Council in the UK, or short EPSRC. So please take a look at the show notes to find the link to the program, where you can also find the announcements of future classes and how to join them. That said, let's jump right into our first session. If you have listened to previous episodes of Code for Thought, you might have stumbled on topics such as open science, reproducibility and FAIR principles, all aimed to make science and the tools we use to do research with more accessible, transparent, and of course, reproducible. And why are we talking about this? Well, because we firmly believe that it will lead to better research and research results, just like what the Software Sustainability Institute in the UK has been arguing for a long time. Better software, better research. Yep, which is all very well, but getting there is a different matter, isn't it? Staying with software, there are quite a few things to consider. Of course, there is the raw code itself. But if other people want to use the software, well, how are they going to do that? How can they install and run it? Are there tests people can run, etc.? Then, of course, there are questions around the legal use of the software by others, or who are the creators and the contributors? Not to mention things like how can I cite the software when I write an article for a journal? In short, when it comes to sharing, distributing and reusing software in research, there are quite a number of questions that go well beyond the code itself. And I guess this is where so-called software management plans come in. Some institutions actually require you to have one if you want to distribute and share your software publicly. And indeed, there are a few templates around that people might want to use as the basis for their software development plans. Richard provided a few links in his online class, and you can find them also in the show notes. But having templates and plans is one thing, using them quite another. As Richard said in the opening remarks, researchers really don't have the time to go through and complete lengthy PDF documents, do they? Which is where Richard's approach comes in to make use of the tools we already use, or at least many of us. And that is using our code repositories such as Codeberg, GitLab or GitHub and add a simple tracking tool, a checklist to it. Richard has been presenting his solution for a while at workshops, not least the collaboration workshop run by the Software Sustainability Institute last year, 2025. I met up with Richard a while later to quiz him on what he hopes to achieve with his checklists, why he created them in the first place, and how you can use them in your own projects.
My name's Richard. I'm the data outputs manager for a research consortium called the Human Developmental Biology Initiative.
Right, and where are you based in the UK?
I'm based at the Babraham Institute, which is just south of Cambridge.
So we're talking about checklists today. And what kind of checklists do you have in mind?
So these are for research software, any software which is used by researchers really, or produced by researchers. I suppose the reason for the checklist was actually inspired by some that I encountered for image data and image data analysis sharing. It was a nice community effort to compose some checklists for that sort of class of research output. I'd encountered a few things, sort of software management plans and such that sort of addressed this for software, but I thought were not quite as approachable as a slightly simpler checklist.
What's your background? So, because we haven't talked about that yet, have we? So, what do you do? Because checklisting is not the only thing you do in your life, is it?
Indeed. Well, my undergraduate degree was in biochemistry and genetics, and I moved into bioinformatics in my master's and PhD. And did work as a bioinformatician in a core facility and as a postdoctoral researcher. And now I'm in this data outputs management role. So I've kind of moved in various sort of research technical professionals and research roles through that little history there.
Well, how did all of that happen? Because, it's quite a route from biochemistry or biogenetics into data management.
I had a summer project that I found quite difficult to do without some bioinformatics skills that I lacked. And I thought I need to go specialize in learning some more about bioinformatics. I already kind of learned a smidge of programming, but not really enough to get by. So I got some professional training, as it were, and then, carried on and learned a lot more on the job as a PhD student. That really got me into the sort of open source software space, right? Exposure to Linux through bioinformatics meant that I learned a lot more about the political side of computation to a degree. And I was always very interested in the open science movement and those sorts of things, reproducible methods and transparency of process.
But you moved into checklists specifically, and I would be interested in finding out actually what brought you to that point where you said, well, this is what's needed.
I was writing a guide for some of the researchers in our research consortium about how to address various research outputs. And one of the things that's on that list is software that's emerging from research. And researchers, they often produce sort of scripts like Jupyter notebooks and other sort of literate programming artifacts and things that are sort of one-off components of their research outputs. And many of the research software management plan type stuff that I had encountered were very much focused on like software packages. But then there's a couple of other sort of things that researchers sometimes also produce. You do get like bioinformatic analysis pipelines, and you get sort of web-based services, which are access to databases and all that kind of stuff. So I thought there was a bit of a gap in providing a advice that was dedicated for each of these different types of output. And if you're a researcher, you're not necessarily going to go digging for some PDF on a research software engineering website, which has some documentation about how to write a research data management plan, right? So a bunch of the advice is kind of not in a place where I think people will necessarily encounter it more organically. And it's not necessarily in a format that is going to be as digestible, right? If you go and read a lengthy and somewhat boring policy PDF, then you're a bit of an outlier even among academics, right? So the mechanism for getting it under people's eyes, I thought, was make it a bit simpler. And so the approach I've taken with the checklists is to have the sort of the checkbox items that you actually check off be visible by default, and then the advice on how to meet the various criteria as a sort of expandable section. So it's actually it's a bit deceptively short. So when you read over the checklist, you think, oh, that's quite attainable. And then when you expand all the bits, you think, oh, that's quite long. So I'm lulling you into a false sense of security with how much effort it's going to take to a degree.
Before then, you actually looked at existing, well, what shall we call them? Plans, not checklists, plans really, like software management plans. Or data management plans. What did you find, and where did you find them, and how did you find them? Was it really difficult for you to find them? Was that the problem that you faced while you created these checklists?
Yeah, it was a bit of a mix of stuff I discovered at various points in the process, right? So I started out with mostly stuff that I was just sort of writing for myself, and then I thought, I'll go and check if anyone else has written stuff about this, because someone probably has, and then did various Googling around for different places. Like the Software Sustainability had stuff, Software Sustainability Institute had stuff. There were a few other research projects in particular domains that had things. I listed a bunch of these in the FAQ on the repo for the software checklist page if you want a more complete bibliography of the stuff that I looked through at various stages of that project.
Well, if you take the software management plan from the SSI, what is it that's lacking in there?
It's not that it's lacking per se. It's just, as I said before, I think it's not necessarily in a place that researchers will go and find it. And I think that some of the stuff is formulated as a checklist, but I think the checklists are a bit too generic in that they don't address the different types of software output. So I think taking an approach that's a bit more specific to the types of output you're generating makes sense.
Which, of course, brings us to your checklist. So how is that different then?
They are divided into those 4 categories that I mentioned. So you've got your record of a specific output, right? And a thing which is like the scripts from an individual paper. You've got web-based services of some kind, so a database, a website, a web application. And then there's 2 sort of units of reproducible code, as it were, so that you've got your individual software packages that are sort of, one language. They go in like a PyPy or a CRAN, like individual software packages. And then you've got sort of analysis pipelines and workflows where you might have strung together a whole bunch of tools in a workflow management language like SnakeMake or Nextflow. They have their own sort of repositories for pipelines and so on. Each of those, I think, has slightly different requirements to think about, but they all fall into the same broad set of categories. I have unifying themes that are in all the checklists. So you've got source control, how to keep track of your history and how to collaborate on things. You've got licensing, the terms on which other people can use the code and how you've communicated that. You've got your documentation, so how do people know what your project is and how to use it, how to contribute to it, making it citable, how would people make reference to the project and credit your work. Testing, how can you be confident that your project does what you think it does? Automation, what sort of tasks can you automate so you have more consistency and less manual work? Peer review, code review, how can you get third-party endorsement and expert feedback on the project? So distribution, where can you put it so that people can access it, software repositories and so on. Environment management and portability, how can you specify the versions that people need to run on their systems? Energy efficiency, how can you minimize the wasted energy? It's governance, conduct, and continuity. How can you be excellent to each other, make good decisions about your software project, continue to do so on an ongoing basis. And there are sort of slight variants on each of those categories for each of the different themes that I mentioned above.
Well, that's quite a long list. So how do people operate these checklists then? Is there literally a checklist in GitHub?
Yes, they're authored as plain markdown files. And the idea is that you can go to the checklist repository. You can take a copy of whichever checklist applies to your project, copy it into your repository. And then as you go and make changes to your project, you might, tick the box off in the same commit that you make the change that corresponds to ticking the box. So you have a track record of, what changed in order to meet those criteria. And that way it can kind of sit there in the project from the beginning and be something that you think about and tackle as you go, rather than it being a sort of big thing that is a bunch of work to do at the end of the project after you've already got a bunch of stuff almost ready to go. So it can be sort of there in the background as something you make progress towards as a part of the ongoing development of the project without it just being a big hunk of work to do right at the end.
Indeed, when we all forgot about what we did at the beginning.
Exactly.
But at the beginning, they need to download it from somewhere, don't they? So there's a checklist, which is a markdown file, is what you said, which probably integrates then easily in, the root directory of a GitHub repo. Or how does all of this work? Where do they get hold of it? I mean, we can provide the link in the show notes, all of that. Then they load it into the project. And then they start using it as they go along with the project.
There's a GitLab repository and there's a website that links back to the raw files in the GitLab repository. So it's rsspdc.org, Research Software Sharing Publication and Distribution Checklists. That relatively short URL for people to remember, RSSPDC. So I think people might be able to get it there.
Is there anything in there that you can automate? Let's say I've created some tests and then it creates a checklist. First of all, is that a good idea that it should be automated? And secondly, is that something that can be automated?
So there are some parts of the checklist that are not necessarily going to entail changes to the repository per se, that are not necessarily going to be a thing that you can check with a process you can put in a CI pipeline, right? The governance questions, for example, are things that are more about, do you have this in a couple of different code hosts? Do you have the right permissions for people to pick up a project? If you have a lab and you've got a postdoc who's done some code development and they leave, can the PI still get into the code repository and pass it on to whomever the next person who's going to take up the project, right? Those sorts of considerations are things that are not straightforward to automate the checking. And I've also not given priority to this being a machine readable format per se. I mean, you could probably automate around the parsing of the markdown for little checkboxes, but it's not necessarily fully robust to something you want to automatically manipulate. Yeah, you might need a machine readable version of the checklists with some in JSON or something.
Yeah, but I was thinking of, let's say that most people, when they open when I say most people, hopefully most people, when they open a new project in GitHub, they select the section where you add a license to it. So you add a license to it. And maybe then there is a way of saying, okay, the file detects automatically there is a license in there, so I don't have to check or tick that checkbox. Likewise with the citation file format, there may be a citation file format in there that helps make the whole software quotable. It could detect that and
certainly be a nice to have. I mean, at the moment, I've tried to keep it code host agnostic to a degree. I don't want it to be dependent on a GitHub specific automation, so it'll still work in GitLab or Codeberg or whatever else you want to host your code. So I mean, it'd be nice to have those sorts of integrations down the line, but it's a bit ahead of where I've got to.
Okay. I want to talk a little bit about computational reproducibility and what that actually means, because I think you gave a talk about your work at some stage. You shared the slides, which of course will be shared with the listeners. But maybe we can talk about computational reproducibility, what it means, and how your work fits in with that.
Okay, yeah, I think a slightly tricky thing to define because it has varying degrees of completeness. For a little bit of the reading I've done around this project, I recently read a very nice master's thesis by someone called Paul Delaria. I think I'm pronouncing that right. And there's also a chap called Konrad Hinson has been doing some interesting work on this for a long while.
And he was on this podcast, funnily enough.
The framing that I think Paul has of Konrad's definition of this is that you have these four criteria, right? There's inspectability, which is the possibility to inspect all of the input of the source code. Executability, the possibility to run the code on a suitable computer and verify the results. Explorability, which is the possibility to explore the behavior of the code by inspecting the intermediate results, making modifications, using code analysis tools, and so on. And then verifiability, which is the possibility to verify that the published executable versions correspond to the available source code. So it's a bit more than just the ability to get a bit-for-bit reproducible result out of the end of the process. And that may not even necessarily be like the level of reproducibility you want. It might be that some degree of error is allowable there, although predicting what that degree of error is can be tricky. So if it's a question of numerical precision, then in something, then maybe that's fine. But if it's a question of introducing something that might change the error in the output in an unpredictable fashion, then maybe it's not fine. So it depends on the sort of domain-specific problem that you have to address. And the security community has been very interested in like bitwise binary reproducible builds for compiled software for a long time for reasons of software supply chain security and so on. So there's a lot of work in that direction. And you have projects like Nixon Geeks doing functional package management stuff where they have full source bootstrappable builds of their compute environment. And that sort of speaks to the two parts of this problem, right? You've got can you actually directly reproduce it? But the other part of it is, can you understand and see how the output was produced? Which is particularly important in the scientific context, right? So, for example, if I have a virtual machine image, maybe I can bitwise reproduce some process, but I still have this black box that is the virtual machine image. So even if I get a bit-for-bit reproducible result from running some process through that image, I don't know precisely what the image is doing, and they're not very introspectable, and they may not themselves be reproducibly built, right? So most of the time when you're building a container image or a VM image, you're using standard package management tools, which might, you can pull from the latest Ubuntu image on Docker. What was latest at the time you built the image, right? Unless you have all those pinned versions, and it gets into those sorts of challenges, which are perhaps better addressed by Nixon Geeks style functional package management, where you don't have those sorts of time-dependent things. If you pin a particular version of the package repository, then you can reproducibly build a software environment, be it a VM image or a container image. But that's a much more succinct representation than a whole container image, which is often a big multi-byte file. Whereas if you have a lock file from a functional package manager, you have probably stronger reproducibility guarantees in terms of the ability both to do bitwise computational reproducible outputs and the ability to reproduce the environment itself that is capable of producing them. Plus, full insight into what actually constitutes that image, because you have the complete explicitly represented dependency tree in a way that you don't get from other package management solutions.
But back to the checklist and how that helps with reproducibility. We talked about various different ways of how we can make software reproducible, what it means, the different criteria that you mentioned, which is very helpful. And where does this checklist that you created or that you use fit in?
So I suppose the goal of the checklist is to turn those principles into some actionable specifics, right? What can you actually do? What properties can your project have that makes it easy for it to actually be reproducible? the stuff like using source control and specifying your dependencies and having good documentation so that people can understand how and why your project is the way it is, so that you can have the explorability aspect of that question available, which is important for the scientific side of things, because you may need to track down why a computation is different in its outputs. There are some other applications in industry and security and so on where that's relevant, but in science in particular, it may be important to know what's the source of this difference in outputs.
Moving on a little bit to another subject, which is the sharing that checklist with others. So you went to the collaborations workshop. It was where was it? It was in Manchester, wasn't it?
In Stirling this year.
Oh, Stirling, sorry. Yeah. Slightly further up north. How did you present it and what did you do with that checklist at the workshop?
Well, the organisers were kind enough to give me a mini workshop slot. So I had 4 groups of 3 people or something to that effect, all able to sit down and participate in a sort of interactive feedback session. So I got to chat with them about what it was. I gave them some discussion points to start off their conversations with and to look at what I had already written for the checklists and to give me some feedback. And the Framer pad for that feedback is still up if people want to look at specifically what people said. It's the text-based stuff is still there. A couple of things that I got from them was... This was originally hosted under the HDBI, my employer's GitLab group that I used. So I moved it over to its own group. So there's not biology in the title, which might off-put some people from other disciplines maybe. And had some questions about things like integration of the energy efficiency section with the Green Disk project that some other people at the conference were working on. And lots of good specifics on maybe this bit's a bit too difficult or this bit's a bit too easy. One of the things that we haven't discussed so far is the other thing that I added to these checklists is tiers at which you can complete them.
Not tiers as in teardrops, but tiers as in...
No, as in levels. Yes,
Okay.
yeah. So sort of a medal system. Hopefully it doesn't make you cry. We shall see. Do let me know if that happens. But so there's a bronze, silver, and gold system, effectively, and then platinum. The idea being that bronze is a very attainable, easy. You can check this box off, and then a platinum as you're sort of going above and beyond and doing things that may not even be necessary in all projects, but there is a stretch goal almost, so steep difficulty curve, right? And the idea being that I could maybe gamify this and get people to think about how can they do more than which I think was one of the other things that I was a bit missing from some of the other checklists and resources was that it's all kind of, this is the bare minimum, but I didn't think there was enough stuff. If you want to go above and beyond in this particular area, here's the things you can do to do even better in this particular regard. Things, for computational reproducibility and such, right? You can kind of, you hit a minimum bar on that or a standard which is sufficient at present, but you can go way out beyond and then have everything in geeks or something like that, where you have that full degree of computational reproducibility, as opposed to just say, I don't know, having a rnf.log file or a poetry log file or something, which is just the language specific dependencies. And then containers might be a step up, right? So you've got the different tiers at which you can complete each of those things.
So in that workshop that you ran, did people go into completely blind, or were they kind of already prepared? We've been trying this, and you're right, I find it also difficult to use the software management plan. Or how was that?
People were very open to the idea. I got pretty positive feedback about it. I think, there's been various, the image data thing was the thing that set me off in this direction, their checklists. And I think there's been various other efforts at checklists in other domains of research output. So I think that was not completely unfamiliar to people and reasonably well-known general concept. So I don't think people found it too foreign. And I think it was quite well liked as perhaps a gentler, easier on-ramp than the full-on software management plan. At some of the higher tiers for some of the criteria in the checklist, do a software management plan is one of the things that I suggest you do. Maybe you don't need one for your couple of collections of scripts, but maybe you do need one once you get beyond a certain scale. That's where I've tried to integrate those concepts. And I think I had someone in the workshop say that they were writing a paper and they'd gone and changed a couple of things in their project as a result of having read my checklist.
What were the questions in your checklist or the points in your checklist that people stumbled over? Were there any? And if so, which ones were they?
That people stumbled over.
Did they stumble over anything?
a number of the disputes I had were kind of around people were saying, we think we should do this a little bit differently. We're more along the lines of maybe I set the bar too low for getting the silver tier in the software packages checklist. Perhaps I was being a bit too lenient on whether or not they needed like automated testing. And then I had a few things that were kind of bigger picture of is the alternative imaginings of how the tiering system might work. Yes, a lot of them were sort of in the specifics or a little bit big picture.
Okay, so having these plans is all very well, of course, and we love to have them or not, as the case may be. But how do you actually get people to use it?
I suppose there are two parts of that question, right? So there's the sort of institutions like requesting people to do it, it being part of policy, and then there's the getting people to do it voluntarily thing, and I think they feed into one another. So there's plenty of places where maybe journals might adopt something like this as a thing that people should do for coders accompanying papers. And maybe some of the existing people who do software review might try and integrate with this kind of program to some degree, or perhaps I could work with them. So, people like CodeCheck and the ROpenSci and PyOpenSci projects and those kinds of things. I mean, they have their own processes, but maybe there's some relationship we could work out between the checklists and the sorts of groups. But for the reasons why people might want to do it themselves and outside of it being imposed on them by some external set of requirements, is that, and I often say to academics, when you go to a conference, who do you want to be to the person who's potentially used your data set or your code, right? Do you want to be the person who cost that person potentially hours to maybe even months in some cases trying to figure out exactly what it is that you did and sort of reverse engineering your project and figuring out the mess of dependencies they had to install to get your thing to run on their compute cluster or whatever, versus the person who, the documentation was great, everything just worked out of the box. It was, it just works. It was a smooth experience. If you put the extra work in for it to be a smooth experience, the soft influence dynamics, you will be well liked by your colleagues in comparison to someone who did not do a good job of documenting their work.
Exactly, the love factor.
Indeed, yeah. And I suppose similarly for if you're offering support, do you want to be offering support for a less well-documented project or a project that's difficult to install as opposed to one that is well-documented? Or even still, do you want your colleagues to have to support your software, which wasn't well-documented?
So how many people are working on this now? I mean, obviously there's you, but is there someone else working on it?
At the moment, it's just me who's actually pushed anything to the repository. I've obviously got feedback from various people. I've discussed this with quite a few people in the Turing Way community at various points. So I've had input from a lot of people, but if anyone wants to directly contribute, I would very much appreciate people getting involved on the GitLab, making suggestions, opening issues and pull requests, anything from my atrocious spelling to an actual more substantive contribution would be very much welcomed. I'd like at some point to write this up as an article that can get published somewhere, maybe a couple of blog posts to sort of to share it around. If someone is contributing, it would be great to have someone on as a co-maintainer to have a good plan for the continuity of the project and governance for the continuity of the project, because at the moment I'm the BDFL, but it would be preferable to avoid me being the BDFL indefinitely.
That was actually my final question, sort of what is the future of this work that you've done? But you answered some of it. Is there anything else that you would like to see happening in the future? I mean, there are the collaborators and the contributors, which you would need in order for the project to continue. Is there anything else you think is missing at the moment and that you would like to see?
I mean, I'd love at some point to see sort of a more complete approach for having, third-party reviewers. I think I might set up a separation between sort of self-assessment and third-party review. And maybe, if you've had a third-party reviewer, you have, a commit from them, which actually adds the repo badge with like a different colored background or something to say this is the third-party review. This other person has attested to the fact that we did this, and I integrate that into some other places.
I think your day job is actually something else, isn't it? I mean, you don't spend all your time on this.
Yes. Yeah, this is a side project that got a little bit out of hand.
As they do.
Yes. Yeah. My supervisor has been very supportive of me doing things like going to the Software Sustainability Institute Collaborations Workshop because it related to writing some guidance for the people in the consortium. I've had a little bit of work time to spend on it, but obviously I've done a bit beyond that in my own time. So yeah, part of the reason why I'm looking for other people to get involved is because I have finite time to spend on the project. So having other people here would be a great help to keeping it going in the long run.
Well, thank you very much for your time, Richard. And I hope that people will
Thanks very much, Peter.
heed your call, and all the best for the future. If you want to find out more about the checklists or use them yourself, go to the GitLab repo Richard created. There you'll find the appropriate files for you to download and use. As I said earlier, all the necessary links are in the show notes. As Richard says, it's not just about your software application or library. Checklists should also work for your workflows or infrastructure projects. The one question we haven't touched on yet: does every single tool or software project need one of those checklists, or indeed a software management plan? Well, I don't think so, because in my past, I often wrote code just to test things out, try new techniques, learn something new, or do a very specific task. Not all of the code we write or workflows and infrastructure we create are meant to last, and that's perfectly okay. But sometimes the things we create, the work we do, take a surprising turn. A piece of software may sometimes become more useful than we originally thought, and be used in different ways by different people. Many successful open source projects, after all, started that way. Take scikit-learn, for instance, or the Jupyter project, at which point it becomes necessary to think about how to share and distribute your tool, to think about the legal aspects of its usage, and to think about how others can learn how to use it. As I said, some organizations actually require you to come up with a software management plan, but keeping track of all the things you need to bear in mind when sharing with others is a good practice all the same, whether required or not. Okay, so we've reached the end now, but before I go, I want to leave you with 2 questions for you to mull over. And here's the first. Richard has 4 different templates for checklists available in the GitLab repo. What are they and what are they used for? And the second one, how does your own project score? As you heard, Richard created different tiers and badges, so why not use the scoring guidelines he provides and see how your own project fares? Finally, Richard is looking for help, comments and suggestions, as you've heard, so please do get in touch with him if you want to help out. For next week's episode, we'll go to Hamburg in Germany, to be precise to DAISY, the German electron synchrotron, which is where I met with Tom White, the creator of a software tool called Crystfell that helps researchers explore the physical structure and properties of materials such as crystals and proteins. And this episode is sponsored by the Step Up project of the EPSRC in the UK, and thank you very much for listening. Oh, time's up. See you next time. But before I forget, this podcast is covered by the Creative Commons license. See ya.